If I put the full screen, you see?
Yes.
That, no?
Yes, it's
okay.
perfect.
So you can see directly. So when you want,
yes,
I can start.
All right. So let me introduce you, and thanks a lot to everybody for joining today. So today we have Francesco Ferro, who is the CEO and co-founder of PAL Robotics. Francesco got his bachelor and master degree in telecommunication engineering in Politecnico di Torino in 2002, master at ICRA, executive MBA at the University of Barcelona in 2011, and since 2004 he develops cutting-edge humanoid service robots at PAL Robotics. And today he's going to talk on a generation of humanoid service robots. Thanks a lot, Francesco. Off you go with your talk.
Okay, thank you very much, Dimitrios. And thanks to ICRA also to give me the possibility to also present a little bit about our company to this workshop. And I'm sorry to say that I will not enter too much into detail, in technical detail, but I will try to show you our development during the years. For this reason, the title of the presentation is A Generation of Humanoid Service Robots. So let me, the possibility to have a couple of slides about PAL Robotics that could be, yes, we did a lot of changing during these years. And this image for me is quite important in order to show all the developments that we did in the last 15 years. So we started in 2004 and up to 2008, more or less, we were only focusing on technology development. So we had one single client from UAE, United Arab Emirates, and we did all the first developments for them with some very amazing platforms that you can see in these slides. And then, up to then, around more or less 10 years ago, we start step by step entering more and more in business detail, and we open different, what we call inside the business units, you will see later, with the different robots that you can see here. So about our expertise, probably you know better than me that robotics is very complex because in order to have success with the real business, real use cases, you don't have only to focus on hardware or software, but has to be also with community and with user and solve needs with the real client. For this reason, we just focus on different, so we did the integration and solve some use cases in different domains. Probably the most important one for us is the R&D, because we are now working with the best university and the best the innovation center all around the world, providing our solution in order to have a boost in their own innovation. Internally, we did this differentiation last year. We developed different business units, like I said before. So one that are very promising is, for example, the retail one. We have an inventory robot taking that is called Stockbot. We use RFID and also vision in order to check all the elements in a retailer. For example, we are working with the 5 best retailers all around the world. For example, one of them is Decathlon that had, also did some months ago a beautiful video about it. And apart from the retail part, there's intralogistics. So we are using all our development about the mobile navigation with our mobile basis, and we put a lot of add-ons in order to make this these roles in healthcare and light industry better. So we have platforms that autonomously are able to transport goods. Then we are quite active in collaborative projects. And like I said before, the most important part are the research. And so for this reason, we have a product for research where we are helping companies and university that in order to develop their own algorithms or to use our platform without taking care of the hardware development, because we did that for them. And recently, we also developed a social robotics unit where we are pushing ARI as ARI, that is artificial robot intelligence. that is a platform for social interaction. But I will not speak anymore on that, and I will focus on the humanoids part. And at the moment, just for finish with the slides with the companies, because I took more than 3 minutes that it was not previous, I want to mention also some European projects where we are active. At the moment, we have around 15 projects open, and like you can see in the categorization ongoing, we have not only healthcare or industry, but also a lot of R&D, and I will speak later on a couple of them in the following slides. But now let's see a little bit our vision about humanoids. And when I spoke about humanoids, at that moment, I will spoke only on legged biped humanoid robots. Okay, so if I have to make a little history and evolution of this field, here you can see different solution. And so PAL Robotics, it was starting their development in 2004, but like you can see, there are a lot of development that was done before. So from the first robot that was called the Televox in 1927, and or in 1920, where Karel Čapek just invented the word robots, we have seen a lot of developments. We have to mention a big effort from Honda that he made ASIMO, that is very amazing robots, and they are still continuing this kind of developments, and it was really, really nice. And another special mention that has to be done is about all the developments from Kawada industry, that it was done with HRP2, HRP3, 4, 4C, and they did a great job. And this is something that is very important for the history of biped robots. And in between all these big developments, we have to mention also our development, that it was our first project that is called REEM-A. So, and we did it in just 1 year in 2004. And it was a robot that was able to play chess. So the idea it was to a robot that is just walking, go near to the table, and able to play chess with a human against a human. And so the idea it was to connect this robot with a big project that is called Hydra, that they did in UAE, that is a supercomputer that is able to play chess against the champion of chess. So it's just to have an idea, 10 times more powerful than Deep Blue, that it was the first computer that won against Kasparov in the 80s. And then after that, we also had other beautiful developments. And so we did our REEM-B, that is more or less an evolution of REEM-A. In 2006, we last a couple of years more than the REEM-A. And we also had an autonomous navigation with a very special solution, that because we had a laser in the feet of these robots. And more or less at the same time, we had also other developments, like you can see the now from Aldebaran Robotics, that now is called SoftBank Robotics, Surena from Iran. A very big effort was done from Italy, from IIT, so the former institute where also Dimitrios was working with the ICAB solution. And also a part of ICAB, they did the common and also other development on biped, so they are a very good inspiration for us about legged locomotion. And another important mention has to be done with the Toro. Toro, that is the first electrical torque-controlled humanoid robots, where you can see here. And from this development that you can see also some of the video, they did a lot of projects and they are very good on that. We had our inspiration to create our also own developments that you can see later, and that is called TALOS. But in 2013, other big steps was done, and we start with our first product for research and development that is called REEM-C. C is just because it's the third evolution of the robots after the A and B, and like you can see, it's a very robust and safe robot. So our idea is not only to have a robot that is able to jump run, make the parkour, like you can see the beautiful Atlas from Boston Dynamics that I was able to do. But it's a little bit different because we want to more and more go near and closest to the real use of the clients, that has to have a robot that is robust, is able to don't fall down and have a good equilibrium and walking without any protection, and at the same time could carry weight. And so for this reason, you can see here the robot where you can just push the robot is able to recover, and having also the torque control where the whole body control where the robot is able to stabilize itself. And we have to mention also in 2013, the development of a Valkyrie, the Valkyrie from NASA, that it was quite nice developments. All these developments was for us an inspiration in order to have another inspiration, I have to say, is Cassie, but yesterday you had already a beautiful talk that I've seen on YouTube about the CTO, from the CTO of Cassie. And now I want to speak a little bit about the Talos, that is our development. We show these robots for real in the IROS in 2018. So if you had the possibility to see the robot, we also shown this video that you can see here in direct, and probably you can also see our some of this demo with the robot that you can just get here. So this is the REEM-A, and the other one is the Talos. And another mention is the slides that you can see in simulation. In the slides, there's a video that it was done for the NASA Space Challenge some years ago, where the robot was able to work, the Talos, in space in Mars, if I remember well. And four people just participate and got to the third position of this amazing competition. And so this is more or less a background about the robots that we developed, but also in the big scenario all around the world. Now just speak a little bit about our own robots. So here you can see the REEM-A. The REEM-A is the robust robot that you can see here. We have a very easy way to also change the hand. Here you can see the 5-finger hand that we did in development, in co-development with University of Pisa, with Antonio Bicchi. And this is, now they also have a product, commercial product that is called from QB Robotics. So purchase it if you have the possibility, because it's an amazing robot. And what we did here is just to have only one motor to close the hand, is to have 3 different motors in order to move the thumb, the index, and the 3 other fingers in an independent way. So the robot here, you can see we are now working with the robots in position control, but we did also different developments for different projects with integrating different cameras, different also here you can see a line array of the microphones here, and the idea is to have a stable working, and we have not to let's say, don't evaluate one of the most important parts, that is all these robots is working with ROS. It's an open platform, and so this is a huge amount of software that was done from our side in order to guarantee that the robot is robust. It can work in a stable way, and could be used also from students. Because one of the first client, for example, was the University of Bauman in Moscow. They mentioned us that they had a lot of good engineers, but all the robots that they had before, it was so difficult to use that it was difficult for the professor to let to the students using these robots because it was too fragile. And so in order to not destroy the robots, they just ask us to have a stable and robust platform. And from this idea, just we had the REEM-A, you can see here, and on the top of this platform, different clients, for example, we have to mention the Technical University of Munich with the department of Gordon Chang, that is also one of the chairman of the next Humanoids 2020 conferences in Munich. They did a different application. And so here you can see a list, a not exhaustive list of application. And also you can see a development that we did for a big, huge museum in China, where we developed an application where the robot has to work 8 hours a day during the working hours in a museum, making this show autonomously. So the robot is able to navigate in the environment and clean a table, sit down on a chair, and all these things in an autonomous way. And the development, for example, that they are doing very well in Munich is about the skin, the robot. That is another sense that we would like to integrate in our robots in order to make also these kind of things easier for the customers, from a customer's point of view. We have also in a project that is called NeoTouch, a PhD that will work with us for 3 years, for the next 3 years, in order to make all this integration with our robots, and are working on this stage. And another things that I would like to mention that is very important is a project that is called Eurobench, where we will have one of REEM-C, of this REEM-C, with a different head, different changes that we did on the platform, will be in Genoa, in Italy, in the IIT facility, where we can use these robots for all the researchers that want to check their own algorithms about, for example, Biped stuff, and to make also benchmarking with their platform. So if you are a researcher and you invent a new robot or you have a new legs, you can just compare with our REEM-C whatever you are doing. And this is in our idea, we think that this is the good approach. So we need to have more and more benchmarking in order to see which kind of robot is better. So how we can compare, for example, a REEM-C or a Talos with an Atlas or with an ASIMO, how we can do this? We need benchmarking in order to see whatever could be good for one application probably is not enough for another one. And so this project has 2 open calls. One is already finished last year, and the other one will finish in 31st of August of this year. And so you could have also money up to 100,000 euro in order to apply, to use the robot, use the facility, and use all this way, in my opinion, to make this kind of biped robots better. And now I would like to pass from the REEM-C to the Talos, and mention you the big development that we did in 2016, thanks to one of the biggest university all around the world that is called LAS, is in Toulouse, in France, and they give us also the requirement in order to have this kind of robots that is completely different from this platform. But this is not only because of the aesthetical design. Okay, this is taller, this is bigger, this is stronger, but also for the most important part, that is the torque control. We have torque sensor in all joints of the robot. What it means? It means that you can push the robot is able to understand the power that you are pushing and the force, external forces that the robot can compensate automatically. Okay, this is completely different from a position control robots. Okay, you can also have here electrical and current control stuff, and so you can make a simulation of this robot. But the important thing is that here the software that you have and the algorithms that you have to write from the torque control are extremely complicated, and so you pass the complication from the position control to the other from a more complex algorithms with the Talos. And the Talos, in order to have this kind of responsiveness of the robot, has a completely new point of view respect to the REEM-C, because we had a header cut. Header cut allow us to have a control loop up to 5 kilohertz. We could have, thanks to that, a torque control also at the joint level. And the good things, for example, compared with the Atlas, is that all this technology is with electrical actuators. That is, means safer for the users. And so you can use all these kind of things safer. And then you could have also other things that it was one of the big requirements, that is the arm that it can carry up to 6 kilograms with arm stretch. So the robot is able also to carry the 6 kilograms in this position. That also for a strong human could be very difficult to stand up to 2 hours like the robot is able to do. So about the different differences between the REEM-C, I've also to mention that also Talos is based on ROS, and one of the most important layer that we have in ROS, and we built from scratch from several years now, is the ROS control. So ROS, probably you know that it was created by the Willow Garage, and they did for the ancient robot that is called PR2. I've seen that there are also still some platform available around the world. And what we see is that this middleware, it was quite agnostic of the robots, but not at the control level. And so for this reason, we put a layer that we put it open source, and so everybody can download and use it with this robot, and allow to have a completely agnostic way in order to use at control level the robots like you said. And now we are doing also the part of ROS Control 2, and so now there's a community that are pushing in order to step the control, the ROS 2 to the ROS Control 2, the version, upgraded version of the robots. And so what we would like to do is also to have even the REEM-C and the Talos working in ROS 2 with these torque control parts. And yes, this is also a beautiful video that we put several years ago on online. And here there's a compliant control stuff that is just to show, but I will show you later after the presentation this this demo on live that probably could be also more amazing. And the idea is to have all this robot that is doing this stuff. And yeah, so let's wait a little bit to have this real part. And another things that we also show in ICRA few days ago is thanks to the MEMO project, that is an European project, the robot working on a debris. So the idea is that the robot can also work in uneven terrain, like you can see here. So probably you can recognize the scenario is exactly the same scenario, and we did a few days ago. So I can pass to you also the link where it was recorded. So today we will do other demo instead of repeating this. The MEMO project is one of the amazing projects in Europe that founded by Horizon 2020 that is memory of motion. The idea is exactly to understand what is better to do with the deep learning, that everybody now is speaking about deep learning, what is better to do with the real control law and rules that we are using, like robotics since scratch, and also remember the movement that it was already done in order to don't repeat all the computational costs that sometimes we are redoing when we have to make a simple motion. And so this project will finish in 2021. All this demo was already previewed to show you in Paris before the pandemic violent closing of everything. And the idea is that we have to work in this project with the LAS in Toulouse and the Airbus in order to have the robot that could climb stairs, like you can see here in the video. Oliver Stasse that is doing some steps with the Talos, and just lifting the screw in the Airbus production line. And now I will just go a little bit to the conclusion that are the classical conclusion that if you already seen some presentation, we always put in this kind of conclusion is that now robotics is something that is exploding. So service robotics is something that is just starting. We started in 2004. And the idea is that it's not only one company, even biggest one can do this work alone. So we have to collaborate, we have to work together, we have to make this kind of robots more and more robust, more and more precise, and we have to give robustness in order to have use cases working for a real world. For this reason, we need to interact with customer from scratch, because if not, you can do a development that is very amazing, but then is unuseful for the real cases. In order to do that, because we are talking about disruptive innovation, we need to have a lot of passion and motivation. This is a must in order to work hard on this kind of platforms. And after this conclusion, I would like to do also some hints to you about the developments that we are doing. Probably you have noticed that we used to do one biped robots every year at the beginning. Then we specialize in order to make a little bit more robust all the code and everything are working more and more in a professional way, like at the point where we are now, where we are working in a new platform that could be more efficient, could be a new mechanical layout. And the most important part is not the ability to jump, that also could be very amazing, but is the impact resistance. And for this reason, we need to also design a lightweight robot. And so the idea is that we would like to have a robot that even if you do all the best algorithms ever that you have in the world, it can also stand up alone without any brain. So we need to have robustness. That has to be one of the first things that we need to do, like a company and like are really dreamers of biped robots, because we will really love to see more and more robots like ours and the other competitors that we have in a real life solving real needs. So say that, I will say to stay tuned and just believe that we are working in order to do this. And thank you very much. Now, if you have any question, please do it.
And thank you, Francesco. This was very interesting. I don't know, Krzysztof, if...
Thank you. I'm looking at the chat. So if anyone willing to ask a question, feel free to put them on the chat. So we will read them and ask Francesco to answer. So are there any questions from the virtual audience?
Francesco, I do have a couple of questions on my side while we're waiting participants to ask if they have any questions. I guess the first question is, so we know that a lot of work has been done in quadrupedal robots, and you know, now we can see them in real world applications, like, you know, inspecting, patrolling, etc., etc. Do you see this coming for humanoid robots? I mean, we know from Boston Dynamics that from their side, it seems that, you know, they are not headed for something like this, at least in the close future. But do you see something like this? I mean, can we use humanoid robots for real world applications at this moment?
Oh, it's a very tough question, and I'm not a magician, so I can't answer. I can give you my point of view. So from technology point of view, I think that we are very near in order to have biped, so with only 2 legs robots that can do some of the stuff. Respect to the maintenance and the inspection, I think that most of the case, a quadruped is a good solution, because you don't need to have a lot of interaction with humans. So interacting with a quadruped, it's good enough in order to work with, you know, in some harsh environment, some difficult environment. And even our robots, for example, if you put in 4 legs, could be used for some quadruped stuff. So for inspection and maintenance, I don't think that the biped robots will be the best solution, except probably in some hazardous environment, like probably we have seen in Fukushima or in other stuff, in other very big disaster that happens in the world, where no robots was able to enter and try to help people and save some life in some way. So in this case, I think that yes, a biped could be a good solution. But at the moment in the real world, I think that we have to go for different solution to have, like I said before, lightness and robust to impact robots. And for sure, I'm 100% sure that we will see in our home, probably not in 1, 2, or 3 years, probably we will take a little bit longer, but we need to have this kind of biped robots also for real use. Just for one simple reason, is that whatever we have created, it was just for us. And so the robot has to use exactly the same tools and the same things that we create for us. So this is my point of view. So service robotics can't go in the same direction like cars that just change all the world. And so we created the highway and everything just for them. But we think that will be the opposite way around. So the roboticist has to just adapt their solution in order to work with the same tools that we used to have. And so the answer for me is yes, absolutely.
Thank you, Francesco. We have our guest, so it is Maximo Roa, who was also like showing up in the video that you were presenting. So the question from Maximo is like an extension of the question. So what would be the, in your opinion, of course, first area of application of humanoid robot at the commercial level? So where is the benefit of using humanoids on a commercial level? So what is your feeling about that?
Firstly, I want to say hello to Maximo. He's a good friend. And so he did also great developments you have seen in the LR with the Toro. He was also in the video. And answering to his question is, in our opinion, the first use of this kind of robots will be probably in production lines. So for example, Airbus and other company needs this kind of robots in order, for a simple reason, is that they certified the process of building something. And remade this kind of certification, it will cost more and more effort and money in order, instead of changing some workers in some specific part, and is not only for cost reduction, but also to save and to just make a reduction of the pain. Because in some production line that we have seen, there are some position where the workers have to take that they can't work for more than 2, 3, 4 years in this position because they will have a physical problem. And so it's not exactly like saving life, but it's saving health. And so in my opinion, this platform could really be very helpful in order to save the healthness also of the worker.
Okay, thank you very much. We have another question from Mayur. Has making a lot of your tech open source hurt your business case in any way? And do you think more companies should engage in open source development to speed up development in the field? Because you are like showing that it could be open source. So could you please answer the question?
So if I understood well, is to having everything open source, or? Yeah,
so on one hand side is how it is influencing your business, and would you recommend like all the companies to be open source to like speed up the development in the field?
Okay. There are different business models that you can use with the open source software. So I can't say that I invite all the company to be open source, because this is something that is difficult also to maintain, and sometimes could be also difficult because open source sometimes is exactly the opposite of having a solution, a stable solution that it works. Because also with open source, and we are quite expert on this field, we have constantly updated upgrades, and sometimes you can lose also some functionality that we had, we already developed. And so it needs a continuous integration and need a big team in order to maintain all the things having, so it's very difficult, especially for a spin-off that is just starting like we did 15 years ago. It was very, very difficult to maintain all this stuff. And so, but from the other side, that for us is all the work that we are doing with the R&D community is very important in order to push the limits. So like a company, we are very open in order to integrate also some solution that was grow out abroad in order to make this robust. And so this is our work, and we have to work in order to make this available for all our customers. So I made you an example. There's the new ROS, like I said in my presentation, the ROS 2. So our work is just to give the possibility to all our customers to use the ROS 2 with our platform. And so without having usually the common use is to have one specialist, a PhD or whatever, that it just took 6 months, 1 year in order to translate all the code from one distribution to the other. And so this is our work, to do this working. And in the industry, especially in production line, is very difficult because it's very stable sometimes and very tough to make this kind of changes. And so there's a trade-off. In my opinion, the trade-off will be the most important part. But now I'm seeing, and we are working with different companies, they are more and more putting effort in open source, because they realize that sometimes also using some solution from big company that you could never understand, then they disappear, because the world in this, even more with this pandemic crisis, is because the company are closing. And so if you have a closed solution, nobody can maintain this kind of code. So this is difficult for a big company, but it happens also to them. And in robotics, we had some big example in the past. And so we have seen some big company that disappear. And this is a mess for robotics, a mess for especially these kind of platforms. And open source allow in some way to maintain this work in order to make it more and more robust for the future.
Okay, so we got another question related also to the interaction that you mentioned and working in the human environment. So both questions are in the same spirit. So one is from Sarah, one is from Andrea to Bure. So it is about the interaction. So we hear about cobots and everything, and how it is met in humanoids. So how we make the humanoids collaborative and safe for humans while working in the environment without cages, without safety scanners, anything like that. Okay.
Probably you have seen that we have also other developments like the Tiago robots that is on wheels that made this kind of, is exactly this one. We have several all around here. And when we spoke about cobots, we always think that we need to have more and more ISO and certification in order to make these robots interacting. And we just misleading that the certification has to be on application level. So there's no robot certified to be a cobot. The technology is enabling the use of cobotics or not robots in order to allow this kind of interaction, but the application has to be certified. So this is one point. And about the bipeds is, I'm 100% sure that you can use a kind of robot that just add, for example, like this, a torque control, you can move and can just detect the movement and the pushing that you can do on the robots, and you can interact. And so once that we will have a clear application and a robust platform that can also fall down and recovery from this fall down, I think that we will not speak about this kind of magic way of having robots bited or not. We will just have technology that is able to do some use cases or not. This is, in my opinion, the real good point. So we need to solve real problem in order to have this more and more platform like this all around the world in real use cases.
Okay, thank you very much. Are there any more questions from the audience?
I have a last one from my side. Right. Do you think it's what is the hardest thing now in humanoids? Is the hardware? Is to develop robust hardware and control, so the mechatronics part, or it is the AI part of the robot to make it work in real applications?
It's tough question. All the things that you mentioned could be bottleneck for sure. But in my opinion, the real big bottleneck is not in hardware, in AI, or in software. It's about integration. The real bottleneck is in integration, because you need to have different specialists that are working in a same platform. So you don't need only the best mechanical engineer ever in order to build a beautiful robot like Talos. No, you need a good control guys, a good electronics guy, and all this integration in order to save, and also to try to have the right trade-off in order to have a good platform with good performances without costing $1 million like Talos, and able to make what the client is asking for. So the real bottleneck, in my opinion, is in the integration part, about the team that has to collaborate also in the design, because I've seen a lot of beautiful biped robots that from a hardware point of view are, wow, wonderful, but then it's impossible to control them. So why you need a beautiful platform that you are not able to control at all? So the integration and the usability is the important point.
Great, thanks a lot for the answer. Francesco, are you ready for any live demo? Should we do it
yes.
now?
Yes, we can do now the live demo, and we can start. So I mentioned before that the breeze with the Talos we already did in another presentation in ICRA, and so you can see the recorded video. It was live also, this video, and so we would like to show you with the REEM-C one demo, and the other one will be with the Talos, and with the Talos will be with the balancing part. I don't know if you are able to see the robot balancing. I think yes. So we will put on this part. Yeah, we can start with my colleagues. Probably you know Adria is one of the best roboticists in the world. So yeah, and now we will put the robot on this part here. A little bit more. Okay. Here it's okay. Yeah. And so this looks like an easy demo, because he said, yeah, no, this is easy to do. But believe me, if you are not using, like humans, we used to have vision and other sense in order to take the equilibrium. And so using only the capacity of like the robot is doing now of the torque control will be very difficult. So I try myself to try to stay stable in this kind of balancing stuff, closing the eyes and just waiting that someone behind is pushing me from one side to the other, and I fall down most of the time. So it's quite difficult to the things. And now you can see that Adria is just moving the robot, the balancing part, and the robot is balancing itself in order to don't fall down. And you can notice here how is moving at the ankle joints, but also in the hip, in order to make all this balancing. And
Francesco, yes. Is this a whole body control, or it's only the lower body that?
No, this is a whole body control. This one. Huh? Yeah, on the but not only whole body control, it's also torque control, because we have a torque sensor in each joint.
Right.
So it's torque control. Okay, we are one of the probably few companies in the world that we also deliver the torque control packaging software that is quite difficult. Believe me, we took several months in order to release it, and yeah, and this is on torque control. And, yeah, we can see these are deleted probably, no? But the idea you can see is that the robot is just moving, and probably we can also move on the hip side in order to see a little bit. Here is a little bit more stuff, and like you can see, there's also protection. When the robot is detecting that is moving too harsh, you just have a protection, a mechanical protection, in order to avoid any kind of disaster, and so it stops from electrical point of view, because imagine this robot could be, is very strong, because like I said before, it can take up to 6 kilograms, so it's very strong. And so we set up all the electrical part in order to see if we have a consumption that is extraordinary. We have a different layer of stops, and this one was from electrical part, and so we stop the electrical part, and then you just reboot, and the robot is just working again. This is the stable version that I mentioned you before, because I remember myself 15 years ago with the first Biped that we had. In order to turn on the robot, we need 5-6 engineers working with a PC in order to start up the controller, then the deployer, then the other, and so different parts at the same time in order to have a vision working, the other working, and releasing this point in order to just have a button to reboot and have the robots working. It was an hard work that we did during these years. And so now you can see the robot is already able to do another time the demo. Probably it was 1 minute for restarting, more or less, around this. And the robot is, yeah.
While we get some extra questions now that you are showing the demo. So is Paolo Franceschi asking, so he says that it seems that Talos versus CASI or Digit from Agility Robotics has more degrees of freedom to control. Do you think this is more reliable or robust?
This is more difficult. This is more than 100% sure that more degrees of freedom, more difficulty in order to control.
But does it give you any advantage over less degrees of freedom, you think, in humanoid robots?
It really depends on the application. So if you want to have a different kind of motion, imagine especially for the legs, no? You have 6 degrees of freedom for each leg. If you need to have special movements in order to climb up on different parts, if you don't have these degrees of freedom, you can't. Exactly, you can't. Then we can discuss and saying, for example, at the moment, depending on the use case, we don't need, and so we made less degrees of freedom. So this is a discussion, but depending on use cases. At the moment, what we did is just a platform that is able to have the maximum degrees of freedom possible available in order to have and make also complex movements, not only with the legs, but also with the arms. We have 7 degrees of freedom from each arm that has to be also torque control at the same time with high frequency. So this is the difficultness of the robot.
Right.
So, yeah.
All right. I think that answers the questions. Great.
Okay.
Krzysztof, do we have anything else from your side?
I think we are happy with all the answers and all the questions. Okay.
If you don't have more questions on the Talos, at any moment, you can ask whatever. We can switch to the REEM-C and making another live demo with the REEM-C.
Perfect.
That is something that could also be nice to see.
Yeah, sure. I mean, thanks a lot for showing us your robots. I mean, the idea was to have everything at ICRA and real there, and hopefully we will do it next year. but thanks a lot for showing the real demo. It's important.
Yeah. Unfortunately, I can't show you the good sun that we have today in Barcelona, but you can see. And I don't know if you can listen the music, but the robot at the moment is dancing. And what is the name of the song?
Over the Rainbow.
Over the Rainbow. So now there's a Over the Rainbow song where the robot is dancing. I don't know if you can listen.
Now we can.
So this was one of the demo that we did with the robots, like I mentioned for the museum where the robot has to dance. We did also a development of the Tai Chi, and some of the movement like this that you can see, it was more from the Tai Chi side than than Over the Rainbow. But yeah,
Francesco, what do you control now? Is it is it keeping?
It's the whole body control.
Is a whole body.
The whole body control. Yeah. So the robot is controlling all the degrees of freedom that he has. So yeah.
Does it respect some constraints such as balance, etc.?
Yes, for sure. It's a balance, the equilibrium, so as not to fall down, you know, and it detects at any moment also if someone is pushing and trying to maintain the equilibrium all the time. And so yeah, it's different platform because this don't have the torque sensor in the joints, okay? But it's just current, impedance control.
All right.
Okay, so yeah, and I don't know if we have other things that to show with the REEM-C. We have to show something else, huh? The same. Okay. Yeah, just to see. And yeah, like a platform. This is our own platform, and it's quite old also. So for this reason, you can see some scratch because sometimes we did some experiment but one of the most important part also with the REEM-C is the possibility to upgrade not only the software but also the hardware. So then I will show you also the back part of the robot where you can just descrew a couple of screws and you could have a full integration of different connectors. So you have two Ethernet, two USB 3.0. You have more possibility to upgrade the robots. You can just take out the power. You can upgrade. And it's a similar concept that we had with the Talos, where you can just connect different camera, different laser, and so we have not to stay on the same development. If we have the robotic part, and so the joints that works will work for a long time. And what we could change and upgrade is the sensors. So don't be scared if tomorrow you will have a new laser or whatever, because you can easily integrate. And for sure, probably you need the driver in order to connect to the PC, but this is a different problem, easier than change completely all the robot stuff. And so, for example, with this robot, we also create a kind of crown in order to put a different camera, and we can also put other microphones in different parts. And so this is more or less the idea. I can show you now the back part of the robots, just to have an idea. Yes. And also another thing, the crane here, like you have seen, is just for security because it's quite expensive platform. And but we didn't use at any moment.
Can I ask you something? What is the energy consumption of these two robots? How much time can the Talos, for example?
The Talos is around 2 hours on his own batteries, and the REEM-C, for this reason, he has a big part here, is around up to 8 hours. but let me say usually on working is around 5-6 hours, fully working with stuff. And here you can see the part stuff, and tenemos llave Allen para abrir. And if I can find also some the key, Allen key, I can take it out this part, and you can see here there's the easy part to close this is just to connect the power of the robots. And here is the possibility. Here probably, I don't know if you are able to see the stuff. I think that this one has to work, but this is not too big. Smaller, I need smaller. The small, I think that is this one probably.
Sí, es la
O even smaller, no, smaller.
¿Esta? Esta sí.
O la que está en el medio,
¿La
que
que
no
está en
tiene.
el medio?
No, es la que está en el medio.
Joder.
I like that we try to open the robot.
Yes, I want to
was not
open the robot.
expecting that.
Yeah, if you have time, if you have to go.
No,
me,
we
it's
do
okay.
have time. I mean, people are,
okay.
Some people are keep attending. And
I'm just stressing everybody because it was not preview, you know, but I like to make this kind of improvisation. So, yeah. And the similar things we have also on the Talos. Here we have the possibility. I can just turn easily. Okay, and so probably you can see here. No, arriba. Here you can see it's similar, and the idea. Wow. Okay. Now you can go down, please. Okay. And so here probably you can see. Yeah. Here you have the possibility to connect. This is the emergency stop button. And so this is another important thing, especially for developer, because yes, if you have to stay all the time near to the robot, you are not near to the PC, to programming and changing the algorithms or whatever. Yes, please, Adria, you can do it. And so the emergency button, at any moment you can connect and disconnect whatever you want. Here you can just turn on and off the PC independently. Here the Talos and also the REEM-A has two different PC. One, we call it the multimedia. And so it's for all the algorithms that you could have, for example, for AI or whatever you need to have the vision and other things. And the other is for control. Here you have also the REEM-A part. Here you can see also here you have the button in order to have software stop mode or hardware stop mode. You have different USB. Here you have also the joystick, so you can control the robot also with a simple joystick. And you can connect also the screen here if you want. This is for safety, the red button, emergency stop button that also in the Talos you can see here. And here you can see the different possibility to upgrade the robot. So the idea is I have a new camera, Ethernet camera. I just have to plug it in, build a little support in order to put it where I need, and that's it, it's done. Here, usually, for example, we have also a back camera that now is not connected, for example. We don't have, but here you could have a back camera in order to have also visual navigation or visual localization on, not only with the camera in front, but also back, in order to make it easier and simple. And the difference, for example, from Talos and from REEM-A is also about the power. So you can connect here the power. You can connect now, for example, when it's on and off, it's completely safe. We did a great job from electronic point of view. So this is more or less the development also with the robot seen from the back. And yeah, and I think with this, I don't know if you want to show something more. I think that with this, if you don't have more questions, we are finished. So
I do have a last question. Do you think it's so? You always say that you know, these are very expensive robots, and do you think we can bring at some point the cost lower? Is it a production problem, or do you think it's like it's something that, you know, it needs a lot of effort to to bring the cost down, so that to be, so that people can even labs can buy, or companies can buy these robots to use them in their facilities?
There are different things. So from one side, there's the question of number. And so you are completely right that if we, for example, instead to sell, we usually sell 1 or 2 bipeds a year, more or less. And so for this reason, for us, in order to maintain this platform, the cost is a little bit higher. So if we can sell a little bit more, I'm 100% sure that the cost will drop down a lot, okay? And so this is question of number, no? Shannon theorem. But then there's also question of development. So what we did, for example, in our robots is the industrial cabling. So for example, here you can see also here in the robot, the cabling, all the cabling are done in industrial way. And if we ask for them to produce 1 or 2 kit of this cable, it will cost a lot. And now, for example, we are also dropping down a little bit the price of these robots thanks to these numbers. And this is just because we did a lot of developments in order to make it robust and professional. Right. And this is one side, okay? So 100% sure that it can decrease a lot. And the second side is also, we really need, for example, just a simple example, we really need torque sensor in each joint. We only need in 1 joint, in 2 joints. And so this is another way to take the same way to decrease the cost. So by design we are decreasing the cost. All and right. So for this reason, like I show in my last slides, what we are working on actively now is to have this kind of design that could be cheaper by design, and at the same time we can produce in probably will not a million of robots, but will be several units in order to decrease even more the cost. So this is what we are working on, and so stay tuned because it's not so far away what we are doing. All right. So especially for research and for the labs and university, we will have a very good, let me say, robots, especially for walking, that will be available soon, that will not cost $1 million.
All right, sounds exciting. Okay, and the last question, and I'm gonna finish with this. I think this came up with from the chat. Sarah asks if those humanoids can collaborate with each other. Have you tried any robot-robot collaboration?
Yes, it's some of the robots that we are working on. For example, the Tiago. I don't know if you can see these robots. Can I take this 1 moment? The Tiago robots.
Now we can see it.
Okay, but this is one of the versions of the Tiago. We have several robots like this. For example, one of the good ones that I love a lot is this one. Are you able to see?
Yes.
This is we call the Tiago Plus Plus, just because it has 2 arms. Okay, and so the idea is to also have, we can also turn on, in the right sense, the principle, yeah, just looking his back all the time is not good. And so with this robot, we are working a project that is called the COFOR Robots, a very amazing project that is coordinated by KTH in Sweden. And the idea is to collaborate robots with 1 arm, 2 arm, even biped, and even only mobile basis, like we have several around here. For example, this one. Yeah, this is just one that we did a pilot with a client. And so the robots can just go from one side to the other and working with, collaborating with them. And so we had several demo, and you can also check on the website of on this project, and you can see how it works in this project. And so the collaboration between robots is not only feasible and possible, but is already a reality because we already did. So here, for example, a simple mobile base. Imagine that this robot is taking a tray and put here and vice versa. So it's something more than feasible. So we are working on several pilots on that.
All right. Okay. Thanks a lot. It's amazing. We have like 5 robots in the screen. That's great. All right. So thanks a lot, Francesco. Thanks a lot, Krzysztof, for handling the questions. It was really nice. I hope that next time we'll meet in person and we'll have some of these robots physically at in a conference. And looking forward for the new platform. I don't know when it's coming. But
soon.
All right, we look forward. It's exciting. So to see what you have new there. Thanks a lot for everything, for this amazing talk and the demos. And thanks everybody for attending and asking questions. I will finish now. Everything will be on YouTube, so I will stop the streaming now and.